This is Mrs. Zappia with Lesson 10, a critical look at proportional relationships. Student outcomes for this lesson. Students work with proportional relationships that involve average speed and constant speed in order to write a linear equation in two variables. Students use linear equations in two variables to answer questions about distance and time. Pause the video and copy the essential question. What is the linear equation in two variables that relates distance and time? Consider the word problem below. Paul walks 2 miles in 25 minutes. How many miles can Paul walk in 137.5 minutes? First, let's determine how many miles Paul could walk in 50 minutes. In 50 minutes, this would be double the amount of time that he has walked 2 miles. If you double the time, you would expect that you would double the distance as well. How many miles would Paul be able to walk in 75 minutes? 75 minutes is 3 times the amount of minutes. So if the minutes triples, then the distance would triple also, giving us a distance of 6 miles. How many miles would Paul be able to walk in 100 minutes? 100 minutes is 4 times the distance. So you would expect, or rather 4 times the minutes. So you would expect that the distance would also be 4 times the amount, which would give us 8 miles. How about 125 minutes? In 125 minutes, what would his distance be? It would be 10 miles. Back to our question, how many miles can Paul walk in 137.5 minutes? Since the relationship between the distance Paul walks and the time it takes him to walk that distance is proportional, we let y represent the distance he walks in 137.5 minutes, and we write a proportion where we have minutes over miles. Minutes over miles. We know that he walks 25 minutes and he goes a distance of 2 miles. And we want to determine how many miles he walks. Let's let that equal y in 137.5 minutes. On the left, this fraction represents his rate, 25 minutes in 2 miles. It is a proportional relationship, and we want to determine in 137.5 minutes how far he can walk. Write a linear equation multiplying each numerator by the other fraction's denominator. Remember, this is called the cross product. So we have 25y is equal to 2 times 137.5. 25y equals 275. Divide by the coefficient. Our value of y is equal to 11. That means that in 137.5 minutes, Paul can walk 11 miles. How many miles y can Paul walk in x minutes? We know that Paul walks 25 minutes and covers 2 miles. Let's start with that. 25 over 2, where 25 represents the number of minutes and 2 represents the number of miles. X over y is the ratio comparing the number of minutes to miles. X represents the number of minutes, and y represents the number of miles. This is a proportion. However, it is also a linear equation in disguise. Now we'll write the equation and solve for y, because it says how many miles y. Writing our equation, we have 2x is equal to 25y. This is our linear equation in two variables. Now we want to solve for y. Divide by the coefficient of y to solve for y. This leaves us with y is equal to 2/25 x. Another way to write this would be to convert 2/25 to a decimal. Pause the video and convert 2/25 to a decimal. 2 divided by 25 is 0.08. This is our linear equation in two variables relating distance and time for Paul's rate of speed. This tells us how many miles Paul can walk in X minutes, where y represents the distance and X represents the time. Remember from our work in the 7th grade Module 1, Ratio and Proportion, how in our table, X represented the time in minutes and Y represents the distance in miles. Why is this equation important? We can answer all sorts of questions now about Paul with respect to any given distance of miles or minutes. Let's go back to the table and look for y equals 0.08x, or its equivalent to 25 x. What do you notice? Here is the 2 and here is the 25 in 2/25 x. The fraction 2/25 came from the first row of the table. It's the distance traveled. It is the distance traveled divided by the time in minutes it took to travel that distance. It is the y value divided by the x value. It's also between each row of the table. For example, between 4 miles and 2 miles is 2 miles, and the difference between the associated times of 50 miles and 25 miles is 25 miles, rather minutes. And this pattern repeats itself throughout the table. You've done this work before, specifically finding the unit rate for a proportional relationship. Remember that the unit rate is y divided by x. And it's the same as the unit rate found using a proportion, and that unit rate is the rate at which Paul walks. Let's look at another problem where only a table is provided. In example 1, this relates the time in hours compared to distance in miles, and this is a different problem. This is no longer Paul. We want to know how many miles, y, can be traveled in any number of hours, x. Using our previous work, what should we do? We can write and solve a proportion that contains both x and y, or use the table to help us to determine the unit rate. We want to know how many miles y can be traveled in any number of hours x. So our goal is to write our equation in the term of y equals blank x, as we did in the problem above. Taking a look at our table, let's label the time, the x value, and the distance, the y value. Then we'll use our first row. You can use any row in the table. We are using our first row. And we want to compare y over x, distance over time. We'll make that equivalent to the first row of 123 miles in 3 hours. This is a linear equation in disguise. Use the cross product and write an equation in two variables. So we have 123 times x is equal to 3y. Now we want to solve in terms of y so that we are writing the correct equation. Divide by the coefficient 3. So we have 123 over 3 times x is equal to y. And then let's write that in the form of y equals, and we'll also simplify 123 divided by 3. Y equals 123 divided by 3 is 41. 41x. This is our linear equation relating the number of miles, y, that can be traveled in any number of hours, x. Y represents our distance. 41 represents our rate. And x represents the time. We're going to continue on the next page. We're going to go down to On Your Own. Exercise 1. Wesley walks at a constant speed from his house to school, 1.5 miles away. It took him 25 minutes to get to school. What fraction represents his constant speed, c? This question is a bit different than the previous one. We are given the distance and we are given the time. And we're not asked to write a linear equation in two variables relating y to x. Here we just want a fraction representing his constant speed. So just a quick review. We know that distance is equal to rate times time. This question is asking about his speed, c. So we want to write the equation in terms of the rate, which is the speed. So if we wanted to solve this equation in terms of rate, we would divide by the coefficient t. This gives us the answer in terms of rate. So rate is equal to distance divided by time. That should look familiar from the previous page. Distance divided by time is the rate. So the rate, that's the same as the speed. So that would be c equals. In our table of x and y, we had time being compared to distance. And we know that in our table, the time is the x value and the distance is the y value. We know that the time is 25 minutes and the distance is 1.5 miles. So we're going to write the ratio comparing these. The distance over the time. So that's y over x, and that is 1.5 over 25. So the fraction, this is part A, the fraction that represents the constant speed, c equals 1.5 over 25. Part B, you want to know how many miles he can walk after 15 minutes. So 15 minutes is the time. Let y represent the distance he traveled after 15 minutes of walking at the given constant speed. Write a fraction that represents the constant of speed, c, in terms of y. The constant speed is equal to, remember, y over x, where y is the distance and x is the time. After 15 minutes, and it says to let y be the distance. So y will be our numerator. Okay. Part C. Write the fractions from part A and B as a proportion and solve to find how many miles Wesley walked after 15 minutes. Okay, so the first, I'm just going to write them here together so we have them. We have 1.5 over 25 is equal to c. And then the other one was y over 15 is equal to c. Since they are both equal to c, they're also equal to each other. So we have 1.5 over 25 is equal to y over 15. Remember, that's the transitive property of equality. Next, write your linear equation and solve for y. So we have 25y is equal to 1.5 times 15. Pause the video and complete the problem to solve for y. I simplified. Next, I'm going to divide by the coefficient. That gives me a value of y of 0.9. That means Wesley walked 0.9 miles in 15 minutes. 0.9 miles in 15 minutes. Part D. Let y be the distance in miles that Wesley traveled after x minutes. Write a linear equation in two variables that represents how many miles Wesley walked after x minutes. We'll start with our proportion. Then I'm going to substitute the rate that they gave us at the beginning. Remember, it's y over x. So that was 1.5 miles in 25 minutes. Then we are looking for the linear equation and for x and y. So we want to use y and x in our proportion. Remember, y over x is the rate. Y over x is the rate. And 1.5 over 25 is Wesley's rate. So step number 2, write the proportion, or step number 1. Then the second step is to write the linear equation. Use the cross product. 25y equals 1.5x. Now, you have to know whether you are supposed to solve for y or x. Remember, let y be the distance in miles after x minutes. Write a linear equation in two variables that represents how many miles. How many miles? So we are solving for y, the miles. To solve for y, we divide by the coefficient of y. y equals. So we have 1.5 over 25 times x. 1.5 over 25. And we can leave it in that form, 1.5 over 25x, where this is the rate or the speed. Remember that y represents the number of miles. The coefficient of x is the rate or the speed, and x represents the number of minutes it takes or hours it takes, depending on the problem, to cover the miles. Let's continue with exercise 2. Stephanie drove at a constant speed from her apartment to her friend's house 20 miles away. It took her 45 minutes to reach her destination. A. What fraction represents her constant speed, c? Okay, so let's recall. We know that distance over time equals rate. That means y, which is the distance, divided by x, which is the time, equals our constant speed. We know that the distance is 20 miles. The distance is 20 miles, and the time is 45 minutes. 45 minutes is the time. So our y value, the distance, is 20. C equals 20 miles over 45 minutes. That is our constant speed. Distance divided by time. Y divided by x. Part B. What fraction represents the constant speed, c, if it takes her x number of minutes to get halfway to her friend's house? Okay, halfway to her friend's house. C equals halfway. Well, she was going 20 miles. Now she's only going 10 miles. And it says to let x be the number of minutes. The number of minutes is the time in the denominator. So this is her rate to go all the way, and this is her rate to go halfway. Write a proportion using the fractions from part A and B to determine how many minutes it takes her to get to the halfway point. So, using the transitive property, if C is equal to 20 over 45, and C is also equal to 10 over x, then we know that 20 over 45 is equal to 10 over x. Now we can write a linear equation and solve for x, and that will tell us the time it takes to get halfway to her friend's house. Writing the equation, 20x is equal to 45 times 10. Pause the video and solve for x. Simplify by multiplying, then divide by the coefficient. X is equal to 22.5 minutes. How far did she go in 22.5 minutes? She went halfway, which is 10 miles. Part D. Write a two-variable equation to represent how many miles Stephanie can drive over any time interval. Okay, so this is where we want to relate y to x. Remember that y equals blank x, where y represents the distance, x represents the time, and the coefficient represents the rate. Our goal is for our equation to look like that, what we need to do is to determine the rate. We can use either the rate of 20 miles in 45 minutes or 10 miles in 22.5 minutes. Let's use the original rate, 20 miles in 45 minutes. Let's relate that. Remember, our goal is to use x and y. And so we write y divided by x because that is the speed. Now, convert that to a linear equation. 45y equals 20x. Now, are you going to divide by 45 or 20? Remember, when you want to solve for y, you divide by the coefficient of y. So divide by 45 on both sides of the equation. And that leaves you with y equals 20 over 45x, where 20 over 45 represents her speed. We can simplify that fraction. That would be 4/9. So y is equal to 4/9 x. This is our linear equation. It is a two-variable equation representing how many miles Stephanie can drive over any time interval. Remember that y represents the distance. Her rate is 4/9, and the time would be x. Let's continue to the summary. In this lesson, we learned about distance equaling rate times time. We rewrote the equation as rate equals distance over time. We know that c is the constant speed, which is distance over time. C is equal to y over x. The purpose of this lesson was to write a linear equation in two variables relating distance and time. We do this by starting with a proportion, where one of the ratios is a fraction of a given distance over a given time, and the other fraction is y over x. Then, write the proportion as a linear equation by writing the cross product. Finally, solve for y. The result is y equals kx. Y represents the distance, k represents the speed, and x represents the time it takes to travel y distance.